Start recording. All right. Things to watch out for with records, the nulls. We've done a lot of work in this chapter getting down to the heart of how we represent values and data using the tools available to us in Java. However, because we're in Java, a certain pesky part of the language is always lurking silently in the background, waiting to undermine all of our modeling efforts at a moment's notice, and that is nulls. That's crazy. So, what happens if you have a person of all nulls? I think it's handled correctly. So, here, I think it's maybe not. Here, maybe the starter itself. This is a big class. And you have, do we have person here? Oh yeah, we do. So let's create another person. Let's create a person. Person 3 is good. Gonna be new person. And it has 3 things. 1, 2, 3. Nope. Person. And we're gonna have null. Correct. Well, I want just null. Null. Cool. Can this be null as well? Let's see. Ooh, that is idiotic. Incompatible type. Okay, so age cannot be. Age can be 0 though. All right. System out. Person 3. Cool. That's where we cd into that ls. We're gonna do that, and I'm gonna just java compile .java. Oh, Java uses unchecked. Let's say recompile with. I guess we have to do xlint uncheck. Oh, I don't want to uncheck it. Okay. Oh, I know where that is. I do know where that is. That was supposed to just be a comment, right? Man. Let's just delete it. And leave it like this for a bit. So this is starter. We're gonna cd in here and Java compile all my Java classes. Now it's quiet. And I will, let's see, Java start. We have all null. That's beautiful. Nulls are a problem in data-oriented view, in the data-oriented view of the world, because they rob us of our ability to trust our representation of the data in code. If something says it's a string, then it should be a string. It should always be a string, so it should never be like null, because null is not a string, right? Well, you can say null is a string, but yeah, whatever. It's not. It's like void, right? And it should never not be a string. Nulls undermine this very, very basic contract. If something is in our domain is only available sometimes, then we want to make that optionality explicit in our data models, so we can have like other things, right? Like optional is gonna come as empty. Should make that optionality explicit in our data model. That optionality is valuable information about our domain. Nulls don't communicate anything because they're bypass mechanism, mm, implicit bypass mechanisms that sidesteps our modeling efforts. So the question here is, what do we want? What do we do about this, if anything? More constructor validations. Is that what we do? So we say, oh, the object requires an object of null. So here, I guess is what they're saying. We want to make sure that the type person, Java, in here, we can say public person, canonical, whatever they call it, canonical constructors. This person object. They're saying objects dot requires non-null type of first, or should I say my insert mode of name, and we also want to do an object, right, of, let's say, head color. Right, cool. So now we've done that. And just to show you, I did not change the program, right? This doesn't know anything about this. So what I'm gonna do is I'm gonna cd back in there as well. I can actually just use something different, do this, but then you're not gonna see the code. So I'm gonna src ls, and I'm gonna java compile all.java, compile safely, java run starts. Now it tells us, hey, this cannot be, it's required, basically. Cool. It allows us to do it here. So at compile time, this happens to be okay. However, I feel, where are we? Okay. So one obvious approach here would be to leverage more validation in the constructor. That's where we enforce the semantics. After all, if nulls break those semantics, then we could filter them out. However, I feel about explicitly defending nulls during construction the same way I feel about explicitly writing out the final keyword everywhere. It can be a useful tool in the beginning, but can optionally be dropped depending on the team's preference and experience level, right? This is important. So yeah, you can write final, but when you have a team approach, right, that is really and when I say a team approach, I mean there is an agreement on how code should be written. You can drop the final and everybody will understand that, hey, this cannot be null and all that. That's what he's saying. So it's not required if the team have a guideline as to what things should be where. So you can have somebody, when you drop the final keyword or you remove this, you can have someone else coming to just like put things that are null in a variable that we have standards about. That's what that means. Programming is a constant balancing act between safety, expressivity, and boilerplate. Sometimes we'll give up one to achieve more of the others. Nulls are one of the areas where I generally choose to give up explicitly checking on the records in favor of improved visibility into the more important semantic validation. This shouldn't ever be null. This shouldn't ever be null. It's treated as a given, right? So, yeah, never be null. Further, throughout the book, we'll learn techniques for evicting nulls from our program. The more powerful we become in our ability to use data modeling to control what we can express, the less of an issue these little gaps where nulls can break through become. Right? When paired with tests, which we'll talk about later in the book, null pointer exceptions, NPEs, effectively become a problem of the past. That is cool. Cool. All right. So this is one solution. Some other niceties that come with records. The expressiveness of records is pretty transformative in a language like Java. What used to take pages of code can now be done in a few lines. While records aren't about reducing boilerplates, the effect they have on boilerplates is darn nice. It's a darn nice side effect. Programming with records is sort of like putting on glasses for the first time after years of thinking that street signs were just printed blurry for some reason. You see things clearly, I guess. The core stuff our programs operate on is laid bare, unshackled by all the noise that used to surround it. You can start to put data types in places where you previously wouldn't have. And even physically lay out your code in ways which previously would have been awkward or visually noisy. That's cool. Local records and classes. Why do I go on the left to get my coffee, man? I gotta stop doing that. This is just for my liking, I guess. Local records and classes. It's super common to need to switch a few pieces of data together, or stitch a few pieces of data together locally in the scope of a method, especially while writing tests. Previously, because creating classes in vanilla Java was expensive in terms of boilerplate, this was usually a scenario where we'd end up sacrificing names and readability in exchange for less tedium while writing the code. The main method of choice here would be tuples, pairs, or other positional based data structure. So you do something like this. Have a list of, so what are we doing here? You have a function that returns an optional other person, so one person. And it takes a list of people, you stream it, and you map it somehow. So you say tuple.off person resolve friends graph. That's a function. I need to know what that means. So it's going to be a person, and I guess it's going to tell you it's like a person to the graph of their friends, I guess, a map. Then you sort it P1, P2, double.compare P1.second, P1.B2.first. Then you map popularity to first, and then you find first. This is crazy. What the hell is this? So first, creating a tuple that requires Okay, we're creating a tuple that pairs together a person along with their friends. Yeah, that makes sense, right? And then we sort. Compare P1 and P second and P first. Access the contents of the tuple by position. More positional access, the further away we get from the tuple origin, the harder it becomes to keep track of which slot holds what. I don't know what that means. Cool. But the positional based tuples are less than ideal in practice. What the heck is in first? This positional problem gets worse the more data you need to stitch together and the more slots you need to fill. What the heck is fifth? Right? Yeah. Okay. The trade-off changes when creating data types is almost gotta stretch. Is almost as syntactically lightweight as creating tuples or lists. It opens us back up to using data to with explicit names gathered than opaque positional accesses. Records are terse. They're simple enough that we can define new data types locally in line, right where we need them. Okay, so you do most popular. Takes a list of people or person types. And then you say record popularity is going to be person, integer, total friends. Oh, so you're doing it by the total amount of friends that a person have. So you do tuple of a person, resolve the graph, sort one person double dot compare. I don't know why somebody's gonna have 1.5 friends though, but sure. 1.25 or whatever. Alright, so you do people.string, you map that person. Say person is gonna have a person, it's gonna have a type of person, and then you have friend graph, right? Comparator that comparing double, you take popularity, total number of friends, and map that to popularity of person, find first. Being able to tersely create data types right where we need them is a game changer for code readability. Humans avoid friction, even if small. Being able to quickly crank out well-modeled and well-named data wherever we need it massively lowers the costs of being explicit and precise. Code layout. The increase in expressivity that record brings to the table can even change some of our core strategies for how we lay out the code in our project. Broadly speaking, Java generally operates under the loose guideline of one class per file. This is totally sane guidance in the world where a single class might require dozens of lines of code just to be minimally viable. Keeping multiple classes in the same file is just too visually noisy. However, when we can tersely express our data types in one line or a few lines, we gain a lot of wiggle room to decide where we want to store things. It can start to make sense to store related data types together in the same file. So you have this interface, card game, you have enum of suits, enum of ranks. Then you have a record of them, ranks, suits, then you have a record of whatever. this small. And why can you fucking put, sorry, a record which is a class inside of an interface? But still learning. This small change can be a massive boon to program understandability. Jeez. It's hard to overstate the joy of dropping into a program and being able to see all of its core data types in one easily digestible view rather than fractured across multiple files. I agree with this statement. If there is a class that is, if you have things or types that are relatable to each other, I think if you have a way of not making multiple classes, it should be in the same class, right? Or the same file rather than a class. I agree with this. I think sometimes you just create too many classes and then you are left jumping around, right? But if you start adding this to a state where it becomes more than a screen, right? So imagine you have this browser here, not this one right here, right? On the browser, if you have a screen, right? This is what we are. Where is it? Where was I? Here. I don't know where I was, but yeah. So imagine you have this code, this bit here, but you have it going. I have to scroll. Maybe scrolling one and a half page is okay, but if I have this code going more than a half page, and I start going this way, time to put a class, time to take it to another file. That's my opinion. But what can I do? Just reading. I think putting them in the same class in a page is really helpful. But if it's more than a page on a computer, I'm sorry, create a new file for it. Good. What's the time? Yeah, gotta take a shower and get the hell out. Maybe tomorrow. Boon to program understandability. It's hard to overstate the joy of dropping into a program and being able to see all of its core data types in one easily digestible view rather than fractured across multiple files. Stacking related data types together like this is an important technique, or is a technique we'll use throughout the book. Java's latest versions have some fun things in store for this kind of modeling. And that's where it comes to like talking about seal types and all that, right? Because one type can be linked to other types. That's what I'm getting at. What to do if you're using, well, I'm not using that. I don't give two craps about it. Yeah, you annotate it with Lombok, the immutable. You say this a value. This immutable interface as well. Create a builder, immutable builder dot. Okay, wrapping up, and that is that. Chapter 3. And we are out of this. What is this? Okay, we go to chapter 3. Let's see what's there. I'm gonna touch node 3. Leave it that way. And see. Let's see what node 2 has. And this way. CD chapter 3. Cool. And here we're gonna have I don't know, V8. we are chugging along. So, see you another time.